Hello, everyone. Hello, everybody. Oh, hello, Chila. Hello, Thiago. Well, hello, everyone that are here with us in Out of the Box Develop Podcast. Well, today we're gonna talk about two interesting topics. I hope we can talk about both, right? Because we know that every time we start talking, we don't stop. So, yay, Chila. How are you?
I am fine. Thank you, Pedro. Happy to be here and learn more about architecture topics, what we are planning for today.
Yeah, nice, nice. And you, Thiago, how are you, man?
Hello everyone. I'm great. Yeah, glad to be here. Hello everyone from the chat. Hello George. How are you?
Yeah, well, we have here George from the chat. Thank you. And we have one friend more. Hey, hello, Douglas. Are you here?
Hey, how's it going? How are y'all doing today?
Yay, we're great, man. Nice to
I,
see you here.
yeah, I heard someone was going to talk about microservices, so I thought I had to jump in and talk about that. I have a lot of opinion.
Yeah, I know you love them, right?
Uh, we'll leave that for later.
Awesome, awesome. Well, uh, I put some links here. Looks like someone has sent already here the links from the Clean Acted blog, and the Clean Coder blog, the one on the links, right? Let me share my screen, and then we can put that on the screen and we can talk about a little. Yeah, the first topic we want to talk here is the clean actors, right? Uh, and I think everybody has seen already this diagram here. I hope yes. If it's anyone in the chat want to talk, work with it, work with system that uses it, it would you can put that in the chat and just comment here. let's let's first talk about the goodness and of course and why it's created like that, right? So, I will start here, but everybody can jump in and talk a little, okay? Well, the clean architecture is an idea from Uncle Bob. Uncle Bob is a polemic guy. Many people like him. Many people hate him. I will not go to the the person here, but the clean architecture is a really interesting idea, right? In terms when you're creating a one system here, right? So we'll talk about one system, like in terms. If we talk about service, we are talking here in one service, right? So when we talk about clean architect, we talk about the architect of one of the servers. So if you're talking to many servers, each service can work, can have his code defined by the clean architect. So that's the main idea when we think about it. It's important to say that because many people think that clean actor can be distributed in different systems or different servers, sometimes mixing things up. So when we talk about clean actor, we are talking about one of the servers, and when we talk about microservices, we are talking about many of these servers. Okay, it's important to make it to make this point. Yeah.
Yeah, just adding one thing because when we read it, clean architecture, we think about architecture, and in this case, it's not really the architecture. It's not like the design of the solution. It's more the
Mhm.
design of the the, the system, more related with uh, the code and the design and applying best practicals like solidity and a lot about deep
Dependency
to keep the
injection.
yeah, and the couple things, it's not more related with the design of the solution, but only a single solution, like one microservice, and not the whole solution, like the communication between microservices and things like that. So, yeah,
Mhm.
a good point to put that in mind. And just about the question that Pedro asked. So here, please, if you can put on the chat which architecture you use in your current project, it would be awesome. So I don't know, maybe clean architecture or MVC or hexagonal or whatever, or I don't know.
Layered,
Yes,
layered
yes.
architecture. Layered architecture, one of the most famous, I can say. All right. Yeah. So the it's interesting to see that the clean actor has this way of like a circle, like inner circles. So, for example, when you see the inner circle here, like entities, they say enterprise business roles, right? When we say entities here, most people work using the idea of domain driven design, right? Because that in a way that you can write your code, your business rules in a code that doesn't depend on any of the infrastructure you're using. That's what clean actor is, right? We create your in business roles using mostly the idea of domain driven design in a way that you don't depend of your infrastructure. When I say infrastructure, what I'm saying here? Infrastructure, I'm saying the way you store data, the way you handle this the you handle the endpoints or service or REST or API or dependency injection or whatever. So so here we are not talking of any entity that relies on JPA, Spring, Flask, SQL Alchemy, or uh, repository, or whatever. So when you're talking about these guys here, they are the idea is that they are just plain objects. Of course, objects that you can validate and so on. But when they interact with each other, they they don't rely on any framework.
Yeah. Yes, I would say
Please.
that, yeah, exactly that. And this is amazing if you think like that, because the
Hmm.
goal of the clean architecture is having that. It's you decouple everything and also the framework. So if you want to change the framework, you can. For example, if you are using Spring and then you want to use Quarks, or if you are exposing your things using
Hmm.
REST API and now you want to change for, I don't know, GraphQL or CLI, you can do that because it
Hmm.
doesn't depend. And yeah, because you have this decouple, and the main thing is the domain. If the domain changes, maybe every layer, every outside layers will change also. But if you want to change only the outside layer, for example, the
Hmm.
framework or the
Hmm.
database or something else, you can
Hmm.
only switch this part. So yeah.
Yeah,
I still
we
I still
that,
think
that
The,
that's
the,
the
the
idea,
point
right?
the point is, yeah, this is the main idea of clean architecture.
Yeah.
But the main question maybe now it's, do you need that?
and that's a
Not
really
not
good
as not.
question, right?
Yeah, that's a really good question. Go ahead, Douglas.
Well, I was going to say that one thing you get by decoupling all of this is you do get the ability to be able to write some really interesting tests at the unit level and even at the integration level, because you can change out where you are, where everything is being written to. And since your interface can be driven by code, you can actually do some of those kind of tests. Now, you never get to the web side of things. Then you have to start doing, you have to start using like Selenium or something to drive those tests, and that's a whole different ball of wax and not what we're talking about. But the thing is that I think that some of the controversy around like such structure, and believe me, when I talk about this, I'm just talking about it from the aspect of I know what the cons are to this too, and it's what all of these are about, which is pros and cons to everything. There are solutions and trade-offs, but there are no like silver bullets ever. I may have just answered the question about what we were about the whole time.
Exactly.
It's like, see, what you pay for when you get all of this is you then have an explosion of classes and interfaces all over the place. And I think that there was even a post on Twitter where the guy was talking about, hey, this is why Java's hard, and it showed like 18 files for one, and I may not be exaggerating, but it looked like 18 files for like one thing. To just do
Hmm.
one thing, you needed 18 different files um, to make it work. So while you get this decoupled, benefit from going this way, and while you get that huge testability, while when you use this, if you're a startup and you need to run fast, you might not want to go down this path at first until you get your MVP out and can prove that you have a viable solution to people's problems. So that's the trade-offs, right? That is
Hmm.
basically what the whole thing. But let's bring it back. Let's bring it back to what if you're an enterprise and you need to write a piece of software that people are going to have to maintain for 10
Hmm.
years? Then, now if that's your audience, then particularly it might be good to have these structures in place so that things can be
Hmm.
replaced over the years. What do y'all think?
Yeah, over the years, sometimes eons. But but what but just continuing, just to get there on what you said, right? When you talk about entities here, you talk about like the business object, right? So, for example, product or user or shopping cart, whatever, right? But we start getting to this point in having lots of files or lots of classes or interfaces when we get to the use cases here. The use case are the one that says, okay, we can do something with it, right? We can do anything that the user really needs. So we use these use cases, and these use cases they call here interactor, right? And when we start doing, for example, add a product to the shopping cart, this is a use case, right? Okay.
Yeah.
In some moment we want to add a product to the shopping cart, like one product to the shopping cart, right? And then it can be called a use case. When we start implementing this thing, we of course we need to say, okay, find this. We have this product here. Find it. Get this. Get the details of this product for me. But when we think about that, I think, okay, we need to get it. It must be stored somewhere, right? It must be like stored in a database or in another service. I don't know. So the use case doesn't know about that. The use case just want, okay, just get me this product for me. And when we don't know how to handle that, what we create? An interface. So we have an interface that will be implemented in a way that can return this product for you. And then you can have another interface that creates a new shopping cart for that specific user if the shopping cart is not already there. So it another thing that we need to store it somewhere. And then, of course, we need another interface that says, okay, get the shopping cart, add this product to the shopping cart. Every time we have these actions that interact and store it somewhere, we need to have an interface because we actually don't know where it's being stored. Every time we have this, we're gonna make this use case here depends on lots of interfaces. you see? So that's the idea here. And then that's why we have these ports, right? Input port and output port. There are ports that these are what they call ports, right? These interfaces.
Yeah.
Every time we
Or
need to,
interfaces.
the ports are the interfaces, but so someone needs to implement these interfaces that we call ports here to actually execute the use case. And this is good in terms of unit testing. Uh, so
Yeah.
everything is an interface. So we just put a mock there and that's it, right?
Right. Right.
Yeah,
I mean,
and not only that, because using this interface, this contract, you apply the dependency inversion principle. So if you want to change the implementation, it's much easier because you only need to have another implementation of the interface and only switch which implementation do you want to use because both sign for the same contract for the same interface. So
Exactly.
it's
yeah.
You define it the interface. You know exactly how the interface must behave. You created the unit test that how it must behave. So every way you implement this interface, it must behave the same. Almost.
yes,
Right? So that's the biggest stuff here. When you think
yes.
about it, say, oh, this
The,
is awesome.
this is the big advantage. You do not
Yeah.
depend on the implementation. You depend on the abstractions. So you can replace these things because you do not depend on the implementation. You don't
Like
depend
Lego.
on how a SQL database works or wherever or a NoSQL database work. You don't do not depend on that. However, these have a cost, right?
You have a cost in
This
terms of
not.
code.
But I
Because
don't know, Douglas, if you want to
let's
add.
put let's put one cost here at least. The one that I hello.
I'm here. I'm here. Yeah, I mean, like we were talking about, like I was saying a little bit ago, is that the cost of doing this is the cognitive load of having all of those classes and interfaces, implementations, interfaces in the system, and then on top of that, you have all of this code now too. So,
Mm-hmm.
it becomes harder to keep everything in your head over time. And on top of that, now, how many times have y'all been in an IDE and you needed to know how something was hooked up? And you had to go into the debugger, like you went into interactive debugging just to see everything get wired up so that you wouldn't have to try to do it in your head. Because that's something that I've had to do in a system that's heavily programmed against interfaces. I'm not
Uh-huh.
complaining, but I'm saying that there is a cost of even being able to read the code in the repo and knowing what's being executed when. That you may even
Mm-hmm.
have to pull an interactive debugger up and start getting in there. So I would say that that's the cognitive load and the ability and the losing the ability to read the code to know exactly what's happening is something that you lose in this architecture. But again, I
Mm-hmm.
mean, uh, it has its place, right, y'all? I mean, in a long running project,
Mm-hmm.
this kind of architecture has a place because, like Diaco was saying, and Pedro, you too,
Mm-hmm.
it's like Lego bricks, right? I mean, you get your classes, and you could just like stick in whatever kind of database you want. You have your entities, and ports and adapters and all of this stuff, and you can just stack it up any way that you want, depending on how you set up your dependency injection, right? Yeah, however you set it up to resolve.
Mm-hmm.
And I love it. First time I ever ran into this kind of architecture or ran into dependency injection,
Mm-hmm.
and the first time I ever ran into it, y'all, was actually using an XML file to do it. So you could
Mm-hmm.
even just modify the XML file on the server and change how the whole thing worked. Now, okay, we don't do
Mm-hmm.
this, right? Actually, we don't even do it anymore. I haven't seen an XML file be the source for how everything wires up in a long time. But yeah, it was so cool the first time I saw this. But
Mm-hmm.
yeah, it's definitely got a cost to it. It's a heavy cost.
Yeah.
You can't
And
just
that
run.
is one cost that everybody says, and at least I feel this problem when I try to work with this thing is that, for example, in a way that is these entities here. They are not JPA entities, for example. They are not any ORM stuff. They are just plain objects, just plain old POJOs here, right? If you talk about Java, but and then what's the problem? When a user case that says, "Okay, let get me this product here," and this product goes to a database, what happened with this implementation? Well, this implementation goes here, right? Goes to some DB, right? And if you're using an ORM, for example, JPA, now we have a representation of products as an entity, and then we have the JPA object that is the database table, right? The products table JPA. You see? So when we call it, we need to transform this entity product to the JPA product, and then ask to the entity manager to make the call, and then we return back with the
No,
product
interface.
you wanted,
Yeah.
and then we need to change
Request.
that back again
Yeah.
to the entity product and return it.
More
Or
interface.
not, and then return to a DTO because you do not want to expose our model.
Yeah,
Yeah.
you can't.
Yes.
So
You don't need to create a DTO because you already have this entity here, right? There is no DTO yet. Calm
Well,
down.
ETO.
We don't have the DTO yet.
Okay.
We
I won't
transformed
go
this
there.
entity to just a moment. Okay, sorry.
No, I was gonna say I won't go there yet. We don't have DTOs yet, so I'm gonna keep listening,
Yeah.
Pedro.
We don't have the details yet. We have the entity. We change it to the JPA model. We turn it back to the entity. Then we need to put that, for example, in the to the web in a REST endpoint. And web needs this own idea of this product object that what we can call DTO right now. So then we get this model there, change to the DTO, and then we externalize it in our controller web framework, whatever it is. I'm using, for example, OpenAPI, so I had to get this guy and transform to a. In my case, I'm working with Python, so I work in a Pydantic model, and then this Pydantic model will turn in a model that is created by the OpenAPI schema. So, man, every time you need to make anything here, we create for a project to have three already, right? Then we have the DB stuff. Then we have the web stuff. Then when we start debugging this thing, we may have all these parsers that changing these three things, and then we have all the tests to these parsers. Well, you
Yeah.
know where I'm getting into.
Yeah.
So
I
now
know.
we have 18 files for adding a product in shopping cart.
so
Just for that.
in short, if you charge per number of lines or per number of class, you should follow this architecture.
Yeah,
If you charge for
if your OKR is I have your
yes,
productivity in number of lines.
yes.
Yeah, this makes us a really huge number of lines in a easy
But
mode things.
yeah, but yeah, I'm just joking. But in short, so if you want to have these decouple things, and maybe you want to change something in the future, like your database or your output instead of REST, use GraphQL or whatever. If you want to have these things decouple, or maybe change the framework, clean architecture can be a
A
really
good
good
thing.
solution because you have these things decouple and it's easier to uh, also chain things because you have the things more decoupled. So it's easier to chain something, maybe chain a controller because if you chain a controller, it will not affect the use case or the entities. So yeah, it will be easier. However, if you use an architecture like that, you have much more files to deal. And like Douglas was saying, if you want to see something, maybe you need to open uh, a lot of class, because you go inside a class, then inside another class, and then inside another, and then you go over 10 class or 15 class only to add a product in the shopping cart. So, yeah.
Exactly.
Yeah. Yeah. I mean, it. I mean, at least we're using composition and not inheritance, right? I mean, that's the one good thing is we're using composition instead of inheritance. But
For sure.
it still your composition now is like a whole Lego Technic build instead of just some Mega Blocks put together. You know,
Mhm.
it's
Yeah. As you said, I think when you think about decoupling, it's very good. For example,
yeah,
I'm working. I created one new service in my current job. That is, it's not a clean architect. Okay, it's just a way that we can have something more decoupled. So now I work in my service in my controller layer that has Open API. I can just I can just recreate some endpoint. I can just recreate the models we have there. Sometimes we need to change the schema because we have to creating new things. And my entity as we work inside the service are still there. And I don't need to I can be like much how can I say uh, I don't feel that I will broke everything internally if I change something in my OpenAPI schema or whatever, right? So it will not break anything. When we create use composition to create a Megazord, George is saying
thank you, George.
here. But yeah, but now I have another service that didn't use that. He just had created something that is completely coupled between the endpoint and the database, right? So the database model in terms of ORM, because in my case Python is SQL Alchemy model, it goes wherever it needs to go, right? It gets to the endpoint, and then in the endpoint it's returned in a way. Sometimes it's returning directly and then just like transform it into JSON and return it, you know. And then every time we need to make any change, it breaks everywhere because all the stuffs are completely coupled, right? This is, and then they said, okay, we need to add an open API scheme on top of this thing. We can't. All these things are completely coupled. And when we start looking, trying to detangle the thing, we said that okay, we can do that one by one, like in a every sprint you can do one, one after another, and then people say, okay, we don't do it because this is all the things are completely are totally tangled, and then we can't untangle that in a one way. So this is the difference, right? When we don't use things like this, the copying things, we start getting something that is completely coupled. This is the I think the completely opposite, right? So we have this
Yeah.
here, well, something that is completely decoupled, and that will have lots of classes. In the other side, we have something that is completely coupled, but man, if you ask me how many classes we have, it's like just a small amount of it. No classes at all. Sometimes it's just functions. Function that call a function that call a function, and that's it.
Yeah. I mean, but
Yeah.
this is the reason why we have options like this. Remember, it's all about trade-offs. There's not one solution that fits everything because if we want to create something fast, if it's not going to live for a very long time,
Hmm.
just to get some investment before we build the really like the enterprise grade solution, then we would go with building something coupled and get it out fast, get it out the door. And then once we have maybe some investment, we come back around and build. And I say this from like a startup perspective, but even in the enterprise, right? Even in the enterprise, we could then build out this kind of architecture so that we have a long running system that might run for years. And you know, then things can change. Life can change over time. The way that we do development can change a little bit over time too, as long as we keep these architectural layers and structure. A lot can change without having to rewrite everything. And Pedro, that's what you just keyed on, was that when it's like 4 or 5 features, it's great. Let's couple everything for a little bit and see how things work so we can do things fast. But if you're building something that's going to be used for years and years and years, you have to go with the discipline of putting together an architecture that is going to stand the test of time and actually be able to bend like a reed in the water with everything going on in tech that we have, right?
Mhm, mhm. Yeah.
Yeah.
I think the problem is it's hard to know these two moments, right? It's hard to know when we know that it's gonna live like for a transition time, or if something gonna live for a long time. And it happens in a startup. So we create something in the first place, right? And then we get to a point that this thing that is started small is now a big mall of mud, and we have this many
Well,
files with 3,000 lines.
yeah, and that's exactly where Uncle Bob comes in. I've seen a post from him that literally talks about, hey, don't use discipline. And what you'll notice is you'll deliver features really fast and you'll get it out the door, but take about 6 months to a year down the road, and someone says that they want to make a quick change to some kind of style or a button, and everyone's like, that'll take a year. It'll take a year
Mhm.
to make that change that you want because we don't know what we're about to break because it's all coupled.
Yes. Uh-huh. Yeah. I think in that book it calls about that, right? They say that when it started getting too hard to maintain,
Yeah,
and
yeah.
it get to a point that nobody wants to put their hands in the thing.
That's right.
That's right. And that gets to a point that people like prefer to start over something than mm, changing stuff inside this thing. Yeah, and this is another stuff like we could. That's why, and this is interesting when we discuss that, because this is the this is when Microsoft starts to get to the thing, right? We start getting something that starts increasing, and then we say, okay, let's separate this thing. So we put this service in doing his stuff, and we create another stuff that do his other stuff, right?
Okay. I think you bring a really good point here, Pedro.
Mm.
So maybe what happen a lot is you start as a startup with some class with a high coupling. So the class talk with them each other and maybe have SQL dependency between them, and then we have microservices. So each microservice has his own domain, and it's kind of low coupling because one should not depend on other, and then you have many microservices, right?
Mm-hmm.
So this maybe solve this kind of problem, right? Because you
Mm-hmm.
can break this monolithic that has a lot of coupling and it's hard to maintain too many microservices. And having many microservices will not have this kind of problems, right? I don't know
Mm-hmm.
if you want to talk a little bit more the benefits of microservices before going to the
Mm-hmm.
draw.
Before talking about the problems, do you want to talk about the goodies about microservices, Douglas?
Okay, so here was the intention with microservices, and it really makes a lot of sense, right? Everything is
Mhm.
a service. Every entity now becomes its own service with its own database, and then you really can switch things out because then you could even use different databases for different entities at this point because it's not one code base now. It's now separate code bases. But here's the interesting trade off that you get.
Mhm.
First of all, service to service communication. How are you going to handle that? Right? It's not going to be any more like in memory because we're going to move out these services into different program spaces, right?
Mhm.
And then the second thing is that uh, are you going to use like HTTP requests where you like hold a you hold the thread up basically every time you want to make a request to do it, or are you going to use some kind of, and here's where it gets fun, y'all, are you going to use some kind of event based system now? Where we're going to put an event bus in, and everything's going to subscribe to the type of message that it takes, and then you have a whole other bit of fun. Now I'm getting into a little bit of the horror story that you walk into, especially if you get like 100 of these microservices in your architecture. And this is where basically, if you have like any semantic wrappers for your, and what I mean by a semantic wrapper is that do you want to write your own like it does every little service need to understand how to talk to another service? Do you write that code inside there, or do you make a library that you share? That's the semantic wrapper, is the library that you share to talk, the client library to talk to your
Mhm.
service. And so
Mm-hmm.
this little thing becomes a dependency that goes out to every single service that calls on that service, and it might actually have a copy of the other service calling this service too. And so you get this
Mhm.
little web. That
The-
web on the right hand side lies. It doesn't look like that. It looks more like that times 50 or 1,000 is what, when
mhm.
you like the microservices and the little X there, like everything's connected like that. It, and here's the problem that a lot of people fall into, and I've been in a company where this has actually happened. What you don't get microservices that run independently. What you get is you get a distributed monolith with which makes you not want to exist every day you have to come into work and make an update. That's what you get, and
Mm-hmm.
people think it's great, and then it's not. So what we have to do when we go into microservices is we have to be really careful about how we let microservices kind of reproduce. How we let them proliferate across the network, and that's the thing, is that what we could do instead, and this is the thing, there is another architecture out there. We're probably not going to talk too much about it, but it's called the modular monolith, where all of these things run within memory, and you don't have to go out and write all of these wrappers. And then what you can do is take and look at your instrumentation, right, and see which services are being a bottleneck at this point. And then if you find one thing that is like making your system crawl, then you take that one little piece, that one little of piece of the modular monolith, and put it in its own microservice. But before that, it basically means expand when you need it. Don't hit the fly with a sledgehammer. Wait till you actually have a uh, what am I thinking? A lion running after you.
Uh-huh.
Wait till you actually have something major coming after you. I was gonna say an alligator coming after you too. Wait till you have something that can cause damage coming after you before you get out the heavy artillery to take care of it, right? That's the thing. And so that's what modular, and I know we weren't planning on going in this direction, I don't think, but really when you think about it, modular monolith gives you a way to kind of have that hybrid of like, go back to having everything be in one program, right, in one application. But then as something starts taking up too much resources in that one application, and you want to scale out in a reasonable way,
Mm-hmm.
Then you can take that one service, you can put an event source out there, and you can do it with the one service, and you didn't make the commitment to have 10,000 microservices floating around with all the
Mm-hmm.
SRE responsibilities that come with it. Like, I've been there, right?
Exactly.
Uh,
Yeah. The SRE of
only,
the problem is a big problem. Go ahead, Chuck.
only one thing here. I really like what Douglas said. I think it was awesome, but I don't know if anyone agree with me. But I think Douglas go really fast. He brings a lot of things. I think talking about modular monolithic, it's very good. It's getting more as a trend topic nowadays. At least I think maybe it's only my bubble, because Spring talks about that some years ago, so it's not new thing. Uh, I think Spring have a project for that maybe 2 years ago or more. So it's not a new thing, but yeah, it's a really good way. But
Mm-hmm.
before going deep again on on microservices and modular monolithic or something like that, I want to bring another subject that I think it's the main focus here. So I think maybe Douglas, thinking in a hack path, let's say that my company is using microservices and it's all right, everything's working. We created, we have few microservices, or I don't know, we use event sourcing and it's working fine. But how about the architecture of my microservice? What do you think? Do you think clean architecture is a good one? It's a good approach? What is your opinion, or anyone else, about what should be the architecture of my microservice? What do you think?
That's a really good question. That is that wow. First of all, hey, if I ever get to the point where I'm speaking too fast, somebody tell me to slow down. Don't let me go like that, cuz I was getting really passionate about what I was talking about because I've lived this before, and I've had to go through what I'm talking about. So that's the first thing. But the architecture inside of a microservice is interesting because here's the thing. Here's the thing. It could be anything your team wants it to be. That's actually one of the advantages of using microservices is that individual teams can take responsibility of it. It puts it on parallel. So if you have a different kind of architecture that your team or language even. So let's say one team wants to work with Rust. It's okay because it'll only be contained within that one team's portfolio instead of out there. But that's another thing that I just mentioned too, is that let me answer your question, Thiago, and then I have a point that I want to make. I think you know where I'm going. The architecture. Who am I to tell you what your architecture inside your microservice should be? But if I was creating a microservice, I would still try to create the layers, so that I can maybe not as complicated as full clean architecture, but something where I can make sure that I can change out my data, my database if I need to. Something where I can change out, uh, the external interface if I need to, which really should always be in a microservice is going to be HTTP, but it could be different. We could be taking calls in through gRPC instead, right? We could be taking calls in through an event source, like a subscription to an event source, instead of actually taking direct HTTP requests. So you still do need some kind of architecture and delineation between the different layers, in my opinion. Again, who am I to tell you how to do things?
Mm-hmm.
I'm just saying how I would look at this if I was creating little microservices to go everywhere. But do y'all mind if I go to that point that I had in mind when I stopped on, or do you want to like talk about what I just said some? What do y'all think?
Uh, I'm open. If you want to keep talking, go
Okay.
ahead. Then we
Okay.
can
Okay.
bring this topic again, because I think this is maybe the main topic, at least. Yeah, I think it's really cool thing to talk about. I like your point. I think we can go deep on that, but if you want to talk a little bit more about what you are talking past, I think it's an awesome talk about micro.
Am I, Thiago? I think we're losing you. Am I? Is it me? Am I going offline instead?
Okay,
No, yeah,
No, I mean,
I
so
didn't hear Thiago as well. I think he's breaking.
Okay, okay. Well, let me do this. The one other thing about one of the pros behind using microservices, and this is why it's so difficult. This is why, people who say programming is easy don't really go into like the problems outside of writing lines of code. This is where the real difficulty comes into play because there's not one size fits all in the way that we put our code together. And sometimes we have to do things that no one's ever done with code. Oddly enough, it still happens. But the other thing, the main thing is that if you are in a company that has teams of developers that need to be working on something at the same time, being in a monolith, not a modular monolith, but being in a monolith is actually particularly challenging because it means you have to deploy every time someone wants to make a change. And so the advantage of microservices, and this is where you have to take in the idea of the costs, right? If you need to be releasing different aspects of your system at any different kind of time based on something going on, and you have all of the instrumentation in place to know that you're not going to blow up someone because they need a new client to talk to you, right? You know who all your dependents are, then you can actually have teams, separate different teams working on things. And that's actually where I've seen microservices shine a lot, is if you have a lot of different teams. But look, here's the problem. If you ever put a team of 7 developers in front of 100 microservices, um, it's no fun, y'all. It's not fun. That's almost like telling someone, like when you you know what, I don't have the analogy. I was going to make an analogy that doesn't make sense, but all I'm saying is that it is pure hell when you put a team of 7 developers in front of like dozens of microservices that they're responsible for maintaining. You slow them down. Where if you have the people on hand, if you have the teams of teams, then you're going to work faster. Parallelism is going to be great for you.
yeah, I think
Um,
Douglas bring a go ahead, Pedro.
no, no, I would agree with Douglas that that it's always I think it's always some we have some balancing to do here, right? It depends on the all the context we have. That's what I that's why I put here this guy that calls Coleman's law, right? They say that the systems are designed according to the how the communication flows inside the company or inside
Yep,
what we're
absolutely. I've
talking.
heard that a lot.
yes.
Yeah.
Yeah, this is awesome to discuss because when we mix the idea of many people working the same thing, we start getting these things, right? I say because people have different opinions, people have different ways of working, even inside the company. Of course, as big as much bigger the company is, as worse this thing became, right? So this is and then we start getting like lots of small silos or lots of big monoliths, right? For different people. If we were talking about monoliths, right? Because in my case, for example, I'm working in a startup, and this monolith is growing. Now we have like many teams working the same monolith, and the monolith is start it gets grower bigger and bigger, and this all
Yeah.
this all this is hard to maintain with many people. So as people start creating services around this big monolith. So I created my own, that other team created their own, and each one is doing his own architecture like that. Not exactly own. They are pretty much similar, but they are not exactly the same, right? So then we have not only one architecture that we need to know, that is the big monolith. Now we have all these different architectures in all these different servers, and then the teams start saying, okay, I don't want to touch the service that from the other team,
Yeah. Yeah.
but
Absolutely,
it
man. Because
needed
yeah.
but it's needed because sometimes
Yeah.
you have your case that needs something. Oh, today I'm having this problem. I was someone asked to make a change in the front end of the system here, and to make the change, we need to change a part of a service that's calling after calling our monolith, you know. And then that service need to be changed, and that service from the other team. And then they say, okay, how are you going to handle that? Are we going to ask them to do it, or we are doing it ourselves? So then we need to learn about their architecture, and then we start getting to this problem, and this kind of problem here, right?
Yeah.
And getting to the
Yeah.
same problem that you said, because you are asking one team to work with different servers that may have different architectures, and then we rolled out
Yeah.
the team.
Yeah, man. I
Yeah.
think I think the best way to go with this kind of thing is that, like, the first time I ever read the description of the modular monolith, I instantly fell in love with that, because I'm like, this is a way to separate it within process, right? We never have to leave. We can stay within process. Everything has the same architecture. All of our tools can still work in the IDE. It can go across and see if we're modifying something that's used by something else, right? Because everything is still in there. But
Mhm.
then, if one little thing starts to act up, if one little thing becomes the bottleneck, that's when we make a microservice out of it, and then we handle it, right? We can handle it gradually, and maybe eventually we do have like 100 microservices that get produced eventually, but only when needed. Only
Uh-huh.
break glass in case of emergency when needed, right?
Uh-huh. And I think I could add, say, how we get to a modular monolith is decoupling.
Yeah.
And I say that to my in my classes, when I say, man, coupling is one of the biggest, most important stuff when we talk about architecture. Not only design of one system, but like microservices in a system design way, right? So all this
Right.
coupling is the biggest problem
Well, and
in
another problem though is,
cohesion and coupling, right? Yeah.
yeah, yeah, yeah. Yeah, cohesion. Your cohesion and coupling are going to be the two levers that can make or break you. You'll crash the helicopter if you don't have cohesive knowledge, right? And so,
Uh-huh.
the thing is that um uh in this sense, right? That you're right in that decoupling is important. It's just that we have to remember, when you start going into decoupling, then your abstractions become extremely important, right? Those interfaces that are going to be the abstraction start to
Mhm.
become super, super important. Your contracts, that's kind of what I'm trying to say. Hey, we have a
Mhm.
comment from George that we never read out here. So, he was saying that
Oh,
microservices is for scale teams. If you have only 7 developers, do not use microservices. And
yeah.
that's what we were getting at, man. And I really appreciate you calling that out, because that's exactly, that was my pain point, when my first experience with microservices. This organization had 126 Git repos. And
Wow.
uh, and actually, here's the kicker: it was a team of 7. They hired me and told me I was coming in as lead, and I had 7 developers, and then they all quit. And so I came in and had 126 Git repos, a build server, and some old documentation. And so I had to go on an archaeological dig to figure out what in the heck these guys were doing before I got in there. So yeah, my taste of microservices, my initial taste was really bad. I had a really bad first impression.
For sure.
I was
I
bored.
can imagine.
And Douglas, at least they use the same technology or not?
It was all C sharp. Yeah, it was all C sharp. So stuff I was really familiar with. It was one piece of technology, but it just looked like someone decided they were going to implement their first iteration, their first try ever of using microservices, and let's just microservice all the things with semantic wrappers, with clients for all the things, and then everything was going through RabbitMQ, and it was just again, I've seen the worst, the
Mhm.
worst it can get, So at least I know that I think it gets better. It keeps getting better as we go along, but I can see the mistakes that happen when people start to bring in microservices. I'm like, you're heading down this path I've seen before. Like, we need to not do this way.
Mhm.
And um, yeah, that's kind of the reason why y'all were laughing when I first came in, because I think y'all had a feeling I was going to come in and blow fire on microservices a bit. I still think, like George said down there, and we've said a couple of times, they have their place. You do need them eventually if your software is going to scale. If you are going to scale your software eventually, it's going to
Mhm.
come into play. But with the idea of a modular monolith, we can gradually implement when we need to implement, and that's the best way. What is it? I don't remember if it was Uncle Bob or someone else who said this, but you need to delay decisions for as long as possible. Delay the final
Uncle Bob.
decision for as long as possible, and you can do that with a modular monolith. If you just decide, I'm going to use this architecture, then you don't have to decide on microservices yet. You can just do your
Mhm.
thing, and then if you need it, you get it.
Yeah. It was Uncle Bob in Clean Architecture. He said that. Yeah.
Okay. Cool, cool,
That's
cool.
exactly the idea. That's why he said, "Oh, we don't need to implement all these outer layers here until you need it."
Yeah.
That's the idea. That's his
People
idea, right?
lose that. They lose that. People actually lose the idea that even the person who put this together, like Uncle Bob, said, you don't need it all at first. Delay decisions. Delay your decisions until you have to make one. And that means you let the system design itself a little bit as time goes on. You know and have the discipline. But then as time goes on, you can add more of these tools that you need to make the architecture cleaner and cleaner as time goes on.
Mhm. Yeah. So what I'm thinking here is, as you said, it's good if we are starting to a modular monolith. It's good to use something like Clean Actor to create this modular monolith.
Yeah. Yeah, I
And
think so, because I think it really looks like that. Like, if you really think about, if you're creating a modular monolith that's you're going to have services in there, right? You're going to actually have service classes that you call, and you'll have integrations between these service classes. But then what happens is that if you create the interface right, and you do have to break one off into its own microservice, then you don't have to change your code that much. Once you have the client generated from the new microservice, it's going
Mhm.
to be pretty seamless, and it doesn't even matter what your interface is. It could be gRPC, or it can be HTTP, or I mean, any other protocol that you want to use, as long as you have the adapter to adapt the communications to
Mhm.
go over to it. Yeah,
Good. Yeah, cool.
I love this
Whoa.
conversation, Will. This
Well,
has been one of my
yeah,
favorite
this is
ones.
a yeah, good, fantastic conversation. Well, I think we are getting to our time. Maybe
Yeah.
we can start answering the last questions here. Like, Well, are microservices and clean actor silver bullets?
I
I
think we
think
have
I think
answered that. I don't know
well,
if you
yeah, I was gonna
can.
say I think we've answered it.
Yes, I don't know if you
Yeah,
can hear me well
summarizing.
because my connection was not so good. So I will try to answer this question, but I don't know if I
Mhm.
can because of my connection.
You can. We hear you
Yeah,
perfectly.
we are
There's a
hearing you. Yeah.
delay.
It's
There's a delay. So if I talk over you, excuse. I do apologize because I do realize I think I've got quite a bit of a delay.
Okay, no problem. I'll try. So yes, I think we have answered that. But in short, I think if you are only one, or maybe a really small team dealing with many microservices, you should maybe not try to use clean architecture because it will be another thing that you need to uh, be aware and to deal with that can make things harder because you need to have more class, more layers, and more microservices. So if you are in a bad case, maybe this is not the best. However, if you are using monolithic or modular, maybe using clean architecture is the best approach because you have a small team or a bigger team and a bigger application. So you probably want to decouple things because decouple things it's essential if you have bigger teams and also more things to deal with because you do not want to change one thing and break another. So if you want to decouple things, go with it. If you need to decouple things, go with it. If you are working alone in a project and it's only you, it's up to you. It's that.
Yeah. Well, I'm going to do my answer to that and say that of course there aren't silver bullets, and microservices is as we said is when we need to scale, and most of the time we don't need to scale that much. Most of the time we're working on internal systems like for corporations, and this internal system won't have like millions of users. So most of the time, in these cases, a monolith is more than sufficient. So of course, working with a monolith has its own challenge. That's why modular monolith exists, right? But even in these cases, we don't need to get to the microservice. We will not get to microservice level, right? We will stay monolith level here when we talk about that, and we are talking about like a plenty of a big market of it. Lots of softwares are doing are written for that. So that's why that's a Microsoft is really if you are thinking of getting to a big stuff like millions of users and stuff. And when we talk about clean act as we discussed, it is the total decoupling thing. But we don't need to total decouple most of the time, right? And we are talking about smaller things or more controlled things. We can like be coupled to some stack, coupled to some database, coupled to some way to interact with external systems, right? That's why we have uh, uh, lots of architecture that handles all these external things for us. And then you don't need to create using clean architecture for that. Think about Rails. Think about Django. Think about Spring. You see,
Yeah.
these guys they have all this coupling with the stack and but they bring productivity. They bring other stuff you can use, right? So not all the time you're gonna need a clean actor. But sometimes we can like be coupled and be happy with it. I know like uh, many startups that just did that, like coupling all this code in Django, for example. And man, they said, "Oh, I work." The CTO said to me, "Oh, I work at 10 years in improving our system here. We get to the point like to millions of users, and we still doing the same Django with all the coupling that Django comes with, you know, in Python Django, I'm saying. So that's why we can say they are silver bullet. We have plenty of opportunities out there that don't use these things.
Yeah. Yeah, I mean, absolutely, right? So, I mean, uh, I think, like I said, I think we've answered this question several times over, but I'll give my summation on this whole thing too, which is Pedro Thiago. I agree. I mean, there is no, and this is the thing that's been said for decades. There's no such thing as a silver bullet. Your results may vary depending on what you use, but here's what the most important thing is that developers keep in mind that there's different levers, right? There's quality, quantity, um, and I think that there's like one more, which is like accuracy. You keep all of these in line, and you know that there's a balance between them somewhere. And I may have misspoke on what the three are, but the idea is if you go in any one direction, like if you go and like increase your speed, quality, speed, and accuracy. If you go like for fast, well, you may lose out on at least one of those aspects that I was talking about. And so the thing is that keep in mind, y'all already said this, productivity. If you want to be super productive and you make the assessment that you don't need the structure, because you're fairly certain you're not going to scale. Famous last words. If you work for a large company and it's publicly accessible, you probably need to build with at least a contingency of a modular monolith so that you don't get caught, broadsided by all an onslaught of needing to do things, right? But if you're building an internal tool, guess what, Pedro? You're right, man. You're building an internal tool. Just use Django or use Rails or use Spring Boot for that, for that matter, right? Just get something coupled up and running and get and change the lives of the people that you're trying to help inside your company, right? That's what we're there for anyway. So like I said, in the end, no silver bullets. I agree with everyone. Um, but the main thing is to understand from a foundational perspective of why you would be making the decisions that you would make to use it. Never make the decision to use microservices because it sounds cool and you saw it on a YouTube video somewhere, and you're going to feel left out if you don't get to use them. Same thing with a modular monolith. Don't use it because I told you to use it or because anyone tells you to use it. Use it because you went and did the research and you understand exactly why you are going to implement something that way. And same thing for the monolith, being fully coupled. Understand why you want to use it and have a reason that's other than I saw it on YouTube last week. I need to do it to like put on my resume. That's it from me, y'all.
Yeah, awesome. Well, and I think our last comment for today is from Federico. Hey, hello, Federico. First time I see you here. It's from Federico. Says clean actors is for monoliths. It doesn't make sense for microservices. It's way too over engineering. Yeah.
I,
It,
I'm
go ahead.
but we're developers, right?
Yeah, exactly.
I agree. I kind of agree with that.
Yeah, I kind of agree as well. Like,
Yeah, yeah, yeah.
of course, in this sense, it's we can say when we talk about that, right? We said that clean actor would be good for a modern monolith, right? So
Yes,
if it is
absolutely.
good for a modern monolith, it's not exactly good for a microservice, right?
Yeah. Again,
I
remember, I yeah. Go ahead.
yeah, I
Yeah,
wouldn't use that
depend on
in.
the size of the microservice. If it's really a
That's what I would say.
microservice, it's yes, you're right. If you have a microservice that it's not a microservice that do many things and it's too big, maybe. But yeah, it depends. But I totally agree with Frederick. Totally agree.
I do too. It's great. I mean that's absolutely correct, right? We don't want to go full blown. I mean, at least if you're keep some layers, maybe. I think we tried to say that earlier. Maybe we said it wrong, but try to keep some layers just so you have
Mhm.
some organization. You don't want to put everything in one file. I mean, please don't do that. Like that, don't do that. But the thing is that um, but keep some organization and do what's comfortable for you and your team because it really is up to you. That's how I prefaced when Thiago said what does a good architecture within a microservice look like. I said, who am I to tell you what a good architecture looks like within your microservice? But I would want some organization in mind.
Yeah, I like to put some layers. I always like to put some layers in any code that I write. No, this is because layers are very a good thing. Like in a small decoupling stuff is good. So I think layering for me is the very first idea. At least three. The idea of three layers. This is my opinion, okay? But I always like to see code like that, at least divided in three layers.
It's a good place to start, right? You again
Yeah.
make decisions at the last point that you can make them. So start with 3 layers, and if you start seeing that there's problems cropping up in this one service, then make a decision about maybe breaking the service, breaking it into a different service, or add some additional architecture to it to make it work. And we could do this if we have
Mhm.
discipline and have the knowledge as we're developing. We can have. I think it's as you do this for a long time, here's what happens. You start to build, even if you're going to say, I'll make the decision later, you will build in a way that it won't be so painful if you have to add something in new because you know what those pathways look like as you go along. You'll design the minimal architecture you design will be extensible, right? I mean,
Mhm.
go back and read some Uncle Bob, right? That would be, there's a lot. Solid, use solid in there, and I think you protect yourself a lot. So again, we are, yeah, Frederico, that's exactly what we were saying. Is keep everything as simple as possible until you have to expand.
Yeah, it's
That's it from me, y'all.
keys and Yagani, right? Keep it simple and you aren't gonna need it. So yes, keep it simple. I think this is the main thing. You probably don't want to have telemetry in thousands of microservices and need to maintain all of that with a small team. So yes, totally agree
Mhm.
with Federico. Uh,
Yeah. Federico has last question as well. How often you guys change the database of a system? How often you change the framework of a
I
system?
love this question.
yeah,
I love this question because this is the one, right? Because everyone says I want to be able to change out my database system, and then
No,
nobody ever changes out their
no, but
database system.
yeah, if it changes,
it
it's a
happens.
big deal.
It
It's
happens, but
huge.
not very often. But it happens. It can happen.
Can
I
But
mean,
it,
the
happen.
code yeah, all your code almost becomes useless at that point because there's several things, not all of it, but to a certain layer, you have to really rethink things because if you're doing things in a relational way, life changes if you're doing things in a document database kind of way. So
For
you
sure.
really do. Frederico, you basically, I think we're waiting to troll. Like it's like let's throw in the wrench right at the end of the show because but it's a great question. I love that, because we really do need to think about those kind of things. What is the likelihood of us changing out our database, which is very unlikely, except, hey, actually, I have one for you. What if your company decides that you're using Oracle, and your company's finally decided they're not using Oracle anymore and they want to go to MySQL? There's a
Mhm.
lot of other pain, but maybe your code could survive. I don't know. It's a hypothetical, so it's fun to play that game. But it's really cool. I really enjoyed this conversation. We've hit way past time. I think we've answered. I hope we've answered all our questions. But
Mhm.
yeah, I think we don't have to worry about changing the database.
For sure.
Yeah.
Well, well, I will ask here if anyone has more comments. You can go to comments, and then we can get here to this live session as in the next time as well, so we can
Yeah.
continue discussing other stuff. We are here every other week, so this week we are here, the next week we are not, but another week we'll be here again, and we can discuss this kind of stuff. That way, if you guys here that are hearing us, if you want to have more about this topic, just put here in the comments, please, and then we can bring another topic that is related to this one, and continue this conversation. Okay, right now we are much over our time. So anybody wants to say his last words for today? Hey, Thiago.
Wait, right. Yeah. Well,
Only thank
actually,
yous,
wait, wait,
and
wait, wait,
keep
wait,
it
wait.
simple.
Hold on, hold on,
Oh,
hold on, just a second. Chilla,
sorry.
you haven't had a chance to speak all day, and
Yeah.
I apologize for that. I want to hear your thoughts.
Uh-huh. Yes. My thought is that I think it's. I agree with you. It's not a silver bullet. None of the solutions. So it's also up to the business problem what you want to solve. So you have the, because many developers they only see things from the technical perspective, but technical point of view. And if there is a new architecture, microservices, or modulate, whatever, what's coming next, the first thing they want to do to apply the latest architecture, no matter whether it's the best solution for the specific problem. So, but maybe you can also look at the problem from a business point of view. What's really the problem? What you want to solve? And I agree with you. If startup, if you are in a startup, then you might have other requirements, or if you know you are just putting quickly together a POC or something like that, then you might not invest that much effort in the architecture. But if you are doing something long living, then you have to think about it deeper. And once you have got a solution, then it's probably a good idea to have a look at it later, how it's functioning in production, and maybe come back later and adjust here and there what's not working. But I think if you have 100 microservices for one person to maintain, then you are just lost. So it's not
Absolutely.
possible.
So then
Yeah.
you
So it's
call
always
Douglas
a
and ask
question of
how to deal with
trade-off.
that.
Thiago, I
Awesome.
didn't catch what you said, man.
Yeah, but I think Thiago has frozen.
Yeah. Yes. I don't know if you can hear me, but yeah, no.
I can hear you now.
Yes, I can hear you now.
Forget it.
Okay.
It was not that important thing. Go ahead.
Mhm.
All right. Well, Douglas, any last words?
No, I think that we've said all that needs to be said today. So I appreciate it. I actually all I'll say right now is that I really enjoyed this conversation and I enjoyed having this conversation with you all. And thank you for being here and thank you for doing this.
Yeah. Thank you, Douglas. Thank you, Thiago. Thank you, Chile. And thank you, everybody who are with us today. Thank you, everybody who sent us comments and questions. And unfortunately, can't go to the last questions here from Frederico, but I invite you, Federico, to come here the next time again, and then we can continue discussing all these interesting topics. Okay. Sorry that we can't continue here. We are already 25 minutes our time. So I hope we can get the next time and then we can continue discussing. All right. Thank you, everybody. See you next time.
See you next
Yeah.
time.
Thanks, y'all.
Thank you.
Bye.
Bye.
Thanks.